was a moment, scientists tell us, when everything began. 13.8 billion years ago, the universe emerged from a state so hot, so dense, that matter itself couldn't yet exist. We call this the Big Bang, though it wasn't really a bang at all, and it may not have been the beginning. This is a contemplation about before, about what existed prior to the moment we call the start of everything, about the strange, beautiful, almost impossibly complex ideas that let us peer behind the beginning itself. If we close our eyes, what do we see? Darkness, perhaps? The gentle dance of phosphenes behind our eyelids? But even in this darkness, there is something. There is our awareness, the space where thoughts arise. The universe too may have never been truly nothing. When we talk about the Big Bang, we often imagine an explosion, a cosmic firecracker going off in empty space. But that's not quite right. The Big Bang wasn't an event that happened somewhere. It happened everywhere, all at once. It wasn't an explosion in space, but an explosion of space itself. Every point in the universe, every atom in your body, every distant galaxy, all of it can trace its history back to that moment. The Big Bang happened here, where you're sitting right now. It happened in the Andromeda Galaxy, 2.5 million light years away. It happened in the farthest reaches of the observable cosmos. Space itself was smaller then, not compressed into a point, but smaller in a way that challenges our imagination. And it was hot, trillions of degrees hot, so hot that atoms couldn't form, so hot that even the fundamental particles we know today couldn't yet exist in their familiar forms. But here's where it gets strange, where our journey truly begins. The Big Bang may not have been the beginning at all. In the 1980s, a physicist named Alan Guth was troubled by a puzzle. The universe, as far as we could measure, appeared remarkably smooth. The cosmic microwave background, the afterglow of the Big Bang, looks nearly identical in every direction we observe. The temperature varies by only 1 part in 100,000. How could regions of the universe that had never been in contact with each other, that were far apart for light to have ever traveled between them, end up at the same temperature? It's like finding 2 cups of coffee on opposite sides of the planet that are heated exactly to the same degree without any connection between them. God proposed something radical. Before the Big Bang as we know it, there was a period of inflation. A moment, though calling it a moment hardly does it justice. When the universe expanded exponentially fast, not just fast, impossibly fast. In less than a trillionth of a second, a region smaller than an atom swelled to become larger than the entire observable universe, doubling and doubling and doubling in size faster than you can imagine, faster than seems possible. This wasn't science fiction. This was a solution to real problems in cosmology, and it changed everything we thought that we knew about origins. During inflation, the universe was cold, empty, desolate, just pure space expanding, driven by a mysterious quantum field, something physicists call the inflation field, that permeated all of existence. This field carried energy, enormous energy, locked into the fabric of space itself. And then, when inflation ended, when this exponential expansion finally slowed, all of that energy had to go somewhere. It went into particles, into matter, into radiation. The vacuum energy of the inflation field decayed, transforming into electrons, quarks, and photons, into all the building blocks of reality. The universe, which had been cold and empty during inflation, suddenly reheated. It became hot and dense, filled with particles. That reheating, that flood of energy and matter, is what we call the Big Bang. So the Big Bang wasn't the beginning. It was a transition, a moment where one phase of the universe's existence gave way to another. Before the heat, there was the cold. Before the particles, there was the field. Before the Big Bang, there was inflation. But this raises a deeper question. If inflation came before the Big Bang, what came before the inflation? Where did it start? When did it begin? And here we encounter something that seems almost too strange to believe. Inflation may never have truly begun, and it may never end. The mathematics of inflation theory suggests something remarkable. Once inflation starts in a region of space, it's very hard to stop. It's very hard to stop it everywhere at once. The quantum field driving it fluctuates, tiny random variations caused by the inherent uncertainty at the quantum level. Most of the time, these fluctuations are small. They cause inflation to end in one patch, creating a bubble, a universe like ours where inflation stopped and particles formed. But occasionally, a fluctuation goes the other way. Instead of ending inflation, it strengthens it. A small patch of space gets pushed back up the energy hill and inflates even faster, even longer. And because inflation causes exponential expansion, these rare upward fluctuations quickly dominate. They grow faster than the regions where inflation is ending. They spawn new inflating regions. which spawn more and more and more. The result? Eternal inflation. A never-ending process where inflation continues forever, spawning bubble universes like soap bubbles in an infinite foam. Our universe, everything we can see, all 200 billion galaxies, is just one bubble in this cosmic froth. Imagine this: universes within universes, bubbles within an eternal sea. This is the multiverse. Not science fiction, but a serious implication of our best cosmological models. If inflation happened at all, and the evidence suggests it did, then it's difficult to avoid the conclusion that it never fully stopped. Somewhere, always, inflation continues. Each bubble universe is separated from its neighbor by vast expanses of still inflating space. The distance between universes is growing faster than light can travel. We could never reach them, never communicate with them, never even detect them directly, and yet they may exist. Countless versions of reality, each with its own Big Bang, its own history, its own galaxies and stars, and perhaps its own life. Some physicists find this idea troubling. After all, if we can never detect these other universes, can we really call it science? Others embrace it as an inevitable consequence of inflation. If the theory is correct, the multiverse comes along for the ride, whether we like it or not. We are in one bubble among infinite bubbles. But there's more to this story. Something even stranger waiting in the mathematical shadows of theoretical physics. String theory. The ambitious attempt to unify all forces of nature and explain every particle suggests that the fundamental constituents of reality aren't particles at all, but tiny vibrating strings. Different vibrations produce different particles, like different notes on a cosmic instrument. But for string theory to work mathematically, space needs more than 3 dimensions. It requires 9 or 10 spatial dimensions, most of them curled up so small we can't detect them. And here's the thing. These extra dimensions can curl up in an astronomical number of ways. Not millions, not billions, but something like 10 to the power of 500 different configurations. Each configuration would produce a different universe with different particles, different forces, different fundamental constants. Physicists call this the string landscape, a vast mathematical space of possible universes. Most of these would be nothing like ours. In some, gravity might be too strong for stars to form. In others, electrons might not exist. Most would be sterile, empty, hostile to any form of complexity. But in that eternal inflation multiverse, Every possibility gets a chance. Each bubble universe could sample a different point on the string landscape. Every configuration of the extra dimensions could be realized somewhere in some bubble. And this is why our universe has the properties it does. Not because it's special, but because we can only exist in a universe that permits our existence. In the vast multiverse, every possibility is tried. We can find ourselves here because here is where we can be. Some scientists call this the anthropic principle. The universe appears fine-tuned for life, not because it was necessarily designed, but because in an infinite multiverse, every tuning exists. We observe this one because it's compatible with observers like us. This explanation troubles many scientists and physicists. It seems to explain everything by explaining nothing. If every possibility exists, how can we predict anything? How can we say why our universe is the way it is, beyond because otherwise we wouldn't be here? It's a question that touches the boundaries of science itself. What counts as an explanation? What makes a theory testable? Can we call something scientific if it makes no unique predictions? There are other ideas about what came before the Big Bang. Alternative models that don't require inflation or multiverses. Some theories propose that our universe is a three-dimensional membrane, a brane floating in a higher dimensional space. Occasionally, two branes collide. When they do, the collision releases enormous energy, appearing to us as a Big Bang. Our universe could be the result of such a collision, and there might have been collisions before ours. Our universe could be the result of such a collision, and there might have been collisions before ours, and there will be collisions after. Other theories suggest that the universe is cyclic. When our cosmos becomes old and cold and empty, far in the distant future, the conditions might allow for a new Big Bang to emerge from the remnants. The end becomes the beginning. The universe breathes in and out eternally. Loop quantum gravity offers yet another picture. In this framework, spacetime itself is made of discrete units, like pixels on a screen. When the universe collapses toward what classical physics calls a singularity, quantum effects create a bounce. The collapse reverses, becoming an expansion. What we see as the Big Bang is actually a big bounce, the universe rebounding from a previous contraction. Each of these ideas is speculative. Each requires physics we haven't yet fully developed, but each offers a different answer to the same question. What came before? All of these stories are attempts to peer behind the curtain of time itself. Yet no matter which story we tell, inflation and the multiverse, colliding branes, cyclic universes, quantum bounces, we always find ourselves pushing the question back one more step. If there wasn't inflation, what created the inflation field? If there are extra dimensions, why do they exist? If space-time is made of quantum loops, what underlies those loops? If the universe is cyclic, what started the cycle? And beneath all these questions lurks an even deeper mystery. Why is there something rather than nothing? Why do the laws of physics exist? Why does mathematics describe reality? Why is there a universe at all? These may be the ultimate questions, and they may not have answers, at least not answers we can understand with our current concepts of logic, causality, and time. Consider what we mean by before. The word implies time, a sequence of moments, cause preceding effect. But time itself may have begun with the Big Bang, or with inflation, or with whatever came before that. How can we speak of before time? It's like asking what's north of the North Pole. The question itself may be malformed, built on assumptions that break down at the boundaries of reality. In the early universe, or before it, conditions were so extreme that our familiar notions of past, present, and future may lose all meaning. Causality may become scrambled. Time may not flow in a single direction, or it may not flow at all. Physicists don't yet know how to reconcile quantum mechanics, where time is an external parameter ticking forward steadily, with general relativity, where time is fluid and relative and woven into space. Until we have a quantum theory of gravity, we can't speak confidently about the nature of time at the very beginning. Perhaps there was no beginning. Perhaps time extends infinitely into the past through an eternal chain of universes, or an eternal inflation. Or perhaps time itself is an emergent phenomenon, appearing only under certain conditions, absent in the deepest levels of reality. We don't know, and this not knowing isn't a weakness of science. It's a testament to its honesty. So, what came before the Big Bang? The answer depends on which story you tell. Perhaps there was inflation, a period of exponential expansion driven by a quantum field, ending in the hot, dense state we call the Big Bang. And perhaps that inflation never stopped, creating an eternal multiverse of bubble universes, each with its own properties, sampled from a vast landscape of possibilities. Perhaps there was a collision of higher dimensional branes, or a bounce from a previous contraction, or a cycle that has repeated infinitely many times. Or perhaps the question itself doesn't make sense. Perhaps before has no meaning at the boundary of time. Perhaps the universe simply is, timelessly, and the appearance of temporal flow is something that emerges within it rather than something that contains it. What we do know is this: the universe exists. You exist. Stars shine, galaxies spin, atoms bond, consciousness arises. Something happened, whether we call it a beginning or a transition or an eternal process that brought about all of this. And remarkably, impossibly, we conscious beings can ask these questions. We can peer back 13 billion years with our telescopes. We can measure the cosmic microwave background and see the fingerprints of inflation. We can build mathematical frameworks that let us explore the first trillionths of a second after the Big Bang. We can wonder what came before, and in that wondering, we participate in something profound. The universe trying to understand its own origins. You are the cosmos looking back at itself, asking where it came from. Here's what moves us most about these ideas. Not the technical details, not the equations or the predictions, but the sheer audacity of the questions. The willingness to ask what came before everything, even when before everything might be meaningless. We are finite beings living finite lives on a small planet orbiting an ordinary star in an unremarkable galaxy. And yet we can conceive of infinity. We can imagine multiverses. We can peer, however dimly, into the earliest moments of cosmic history. This is what consciousness does. It reaches beyond itself. It asks questions that may not have answers. It builds telescopes and mathematics and theories, trying to grasp the origin of all things, including the origin of the minds doing the grasping. Perhaps that's enough. Perhaps the search itself, this reaching toward understanding, is what matters, not the final answer, if there even is one. So when you look up at the night sky, remember, those stars are echoes of the Big Bang. The light you see left them years or centuries or millennia ago. But the atoms that make up those stars and the atoms that make up you were forged in processes that trace back to that first hot, dense state. And before that, perhaps there was inflation. And before that, eternal inflation. And before that, we don't know. Perhaps there was nothing. Perhaps there was always something. Perhaps the question dissolves when we look at it closely enough. But in this moment, here and now, the universe exists. It thinks, it wonders through you, through every conscious being. It asks about its own beginning. And that, perhaps, is the deepest mystery of all. Not what came before the Big Bang, but that there's something capable of asking. There may be no ultimate answer to where everything came from. The chain of why and how may extend infinitely backward, or it may loop back on itself, or it may end in a paradox where time itself becomes meaningless. But we can still do what humans have always done: tell stories, build models, test them against observation, push the boundaries of understanding a little further, knowing we may never reach the end. Before the Big Bang, there was something. What that something was: inflation, a quantum foam, colliding branes, nothing at all, we're still trying to understand. And in that trying, in that reaching toward the unknowable, we are most fully human, most fully alive. The Big Bang happened. Before that, there is mystery. And maybe mystery is where we're meant to rest. Not in ignorance, but in wonder. Not in certainty, but in the beautiful, terrible, awe-inspiring recognition that reality is stranger and grander than we can imagine. You are part of this story. Your atoms were there in some form at the beginning, or before the beginning, or in the eternal process that has no beginning. And now those atoms are arranged in a way that they can wonder about their origins, their own origins, that they can ask what came before. This is the gift, not the answer, but the question, not the destination, but the journey. Before the Big Bang, there was mystery. After the Big Bang, there is still mystery. And in between, there is us, brief, conscious, wondering. Maybe that's all we need to know.